6.4, calculate the minimum mass of calcium carbonate that must be added to the container to achieve equilibrium. So the question is here that we don't have any information about calcium carbonate. That is what we need to find as answer for this question. So this is the question where you need to set up your table. So I always set it up where I start with my balanced equation, the one that's given, and then my table is set up like this. The initial mole, the react or formed mole, that is your change in mole, your equilibrium mole, and then your equilibrium concentration. So the question mark is under calcium carbonate because that is the question, that is the information that we need to calculate this answer. Now for calculating Kc, now Kc was given in this reaction as 0.0108. Now remember, there's no other information available, so that is actually the information that you need to work with. So if they have given us the Kc value, and Kc only uses the concentration of gases, please take note that in your balanced equation you have the solid calcium carbonate and solid calcium oxide, so that does not become part of the balance of the Kc calculation. Only use gases because the concentration of solids remain constant, so they don't go into the Kc expression. Right? So the given Kc value is then actually the concentration of the CO2 gas. So that can now go into my table under equilibrium concentration. So that will go in here, 0.0108. But they told us that the volume of this container is 5 cubic decimeters. So with that information, I can then fill in the equilibrium mole. And that is N equals C times V. And the concentration 0.108 times 5 is 0.054 mole. Okay, so now I've got my equilibrium moles. Now they told me that the 2,2, I've got 2,2 grams of CO2 in the beginning. So that 2,2 grams can go under initial mole. So there, N equals M over big M, and that is 2,2. And for 44, the molar mass is for CO2, the molar mass is 44, and that gives me 0.05 mole of CO2 that I have available in the beginning. Right, and now I will carry on by completing my line here, which I like to call my ratio line. Why do I call it that? Because everything in this line must be in the same ratio as the balancing numbers of my equation. So I then say the following. If I started with 0.05 mole and I ended with 0.054 mole, then the difference of those two will be 0.004 mole. Therefore, I now know that I have 0.004 mole of calcium oxide as well as 0.004 mole of calcium carbonate. Right? So if I then think along the lines of at equilibrium, well, I had a certain mass of that and a certain amount of that reacted. So the question is, calculate the minimum mass of calcium carbonate that must be added. Therefore, all of this will be used. So at equilibrium, I will have nothing left. So that brings me to 0.004 mole of calcium carbonate needed in the beginning. And then if I know what that is, I can finalize my answer. I can say, well, then the minimum mass needed of calcium carbonate equals N times Mr, and that's 0.004 multiplied by 40 for calcium, plus 12 from the periodic table, plus 3 times 16 for the 3 oxygens, and that gives me 0.4 grams.